Good morning, everybody. Yesterday we stopped at the 11th point, earthing of electrical appliances, means electrical devices which we are using in the houses, like a refrigerator, electrical irons, or any electric stove, etc. Their body is made of the metals. By any reason, if electric wires, power supply, having the power supply connect to the body, and if you touch it, the current will try to pass from your body. Our body is a conductor and passes from the human body to the ground. So you get the electric shock. To avoid it, the surface or cover of these electrical devices is connected to earthing or connected to the earth. For that earthing, we have the three wires coming from the power stations. One is called as a line, another one is neutral. Okay, these two are coming from the power supply, okay, electric generators. Another one is earth. Earthing is done in the house, near the house only. Near the house, a pit is dug and coal pieces and salt and water is poured into this, and good conducting rod or pipe is connected here, fixed into this, and electrical wires are taken from it. This is nothing but called as a earthing. Earthing symbol already we have discussed this earthing symbol. And from this connection is taken and to connect it to the one pin, which is a bigger pin in the power plugs. We have the 3 pin plugs, means one is live, that is actually having the power supply. Neutral is also earthing only, but it is coming from the power stations. Okay, these two coming from the power stations, and current is present only in this live wire, not in the neutral wire. So, and earthing is connected, that is a bigger pin is connected to the earthing near the houses. And what happens in case this neutral wire is no problem. If you touch the neutral wire, nothing happens. But if you touch the live wire, you get the electric shock because current tries to pass from the live wire. This power current is in this from our body to the ground. If you are on the plastic chair, insulated chairs, and if you touch the live wire, nothing happens because current is not passing to the ground. It just stops at your body but not going down. Current always requires a closed circuit or closed path. So if you touch this by sitting on the plastic chair, nothing happens. But if you touch this by standing on the ground, also nothing happens. Okay, because there is no current in the neutral wire, and electrical also nothing happens. Okay, but in this device, electrical devices, by any chance if the loose wire is there, then live wire is connected to the body. Body is made of the metals, and by chance if you touch the body, you get the electric shock. To avoid this problem, what is done is this is called a short circuit. Current is not passing the device inside the motor, but is passing directly from this metal surface. So in this case, the surface is connected to this earthing, which is nothing but connected to this earthing near the house, near the house. And whenever the current is, if the wire is touching the body, the current passes through this body to the earth. And even if you touch also, nothing happens here. Or fuse wire is kept here. Fuse wire is kept here for the live wire. Fuse wire must be live wire for the live wire. Switch is also not for the live wire. In these cases, when the current is passing a large amount, whenever the current is directly passing to the earth instead of passing to the motor, etc., electric device inside, the current will be very high. Whenever the current increases to large values, the fuse wire will be heated and breaks, melts and breaks. It is made of the low melting point metal, and it bends easily and breaks the circuits. That is the advantage of earthing. So earthing is done in the houses to protect the electrical devices also, and to avoid the electric shock from the devices if there is any loose contact of the electrical wires inside the devices, or the electrical irons or the fridges and other devices. And the body is made of the plastic, there is no such for earthing is required. And during lightning the voltage coming from the current electron jumping from the clouds, they are the very high voltage, and they can jump from the cloud to this earth to that long distance, means jumping through these gaps in the switches is not difficult for them. So during the time of lightning time, you have to remove the plug. Just switching up does not save the electrical devices. To save the electrical devices like sensitive TVs, then you must remove the plugs instead of switching it off. Then only you can save the sensitive electrical devices. Next, 12. Charges leak easily from sharp points, of the objects into atmosphere. atmosphere. If you have the sharp points for any object, and if you are putting the charges, charges will leak out easily from the sharp surfaces. But if you take the sphere, if there is smooth sphere if you have taken, okay, sphere don't have the sharp edges. So sphere, if you take the metal sphere and taking the charges, and will not be metal sphere, any object with this charges. Take the sphere, and then I take the cube, rectangular surface. If you are putting the charges on this sphere and also on this sphere, on this one is sphere, other one is a cube or cuboid. This one has a sharp edges, sharp corners. If the sharp corners, charges will leak out into the atmosphere more easily. But here, charges will be sitting on the surface, outer surface. Here also sitting on the outer surfaces. But here, charges lost very quickly compared to the sphere. Sphere can hold the charges for longer time compared to that of any other surface object which has a sharper corners. Okay, how it is losing the charges to the surrounding atmosphere? If you put the charge body in an atmosphere room, after some time it gets discharged. How did it get discharged? Discharging means losing charges. So here, this charge is present. If air molecules comes, air molecule is electrically neutral initially, but it has both positive and negative charges. In this air molecule, the plus attract the electron towards it. So when it becomes plus, electrons comes one side, other side losing electron, the same molecule only, electrons hold one end and the other side becomes equal to comparatively positive. So this attraction takes place. This air molecule comes and touches with this. Whenever the air molecule touches with this, minus and plus recombine. So electron goes to this body sphere, and the electron goes, this means the electron is lost by this, but remaining plus is there. Now already sphere has a plus repulsion. The air molecule go away. It looks like, now after the air molecule goes away, the sphere is losing one positive charge here. Air molecule comes and neutralizes one charge and going out. So what happened here is the sphere lost one charge. Like that, surrounding air molecules comes, touches and then takes the charges away. Here in this case, the charges are lost for any body in this process by the surrounding air molecules. If the humidity is there, if air molecules contains the water molecules, then they pick up, instead of one charge, they pick up multiple charges. So water molecules are there in the air molecules, water actually insulated, but when water is mixed with any other material, no. It is a good advantage. Whenever the air molecules are mixed with water molecules, during moisture atmosphere, during rainy season, these electrostatic experiments fail. Why? Because the air molecules come with the moisture and picks up the charges from the body very quickly, so that the body loses charges more quickly during the rainy season, during the humid regions. And even the dry region charges are lost very slowly. For the sphere, very slowly, and uniform distribution is also there. For the sharp body, what happens here is, at the sharp body, the air molecule comes and surface area is less at the sharp surface points. The air molecule comes and picks up more than one charge from the sharp bodies. So at the sharp bodies, the charges are lost more quickly. Okay, and here the charges are lost very slowly. So any body having the more sharp points, if you take the conical surface, charges are bigger than this. So charges will be lost from this sharp end very quickly. In case if you take one candle flame near to this. Candle flame, if you keep it near the sharp corner, you can easily notice that the air molecules are going away. Means wind is produced at this point. Stationary molecules, wind means blowing air. The air molecules come and pick up the charges, and by light charges they get and run away. That means air molecules are going away and pushes the flame right side. In this diagram, here the flame will be bent in the direction of flow of this air. That is indicating that charge. Air molecules are coming and picking up the charge. So from sharp edges, air molecules are lost very quickly. This is compared generally with the heat loss from our body. In the winter, we feel more cold to the nose tip, sharp edges, ear tips, sharp points, fingertips, sharp points, leg fingers. So these sharp points will be from the points we are losing more heat. So we feel losing heat means we feel cold. So due to that reason, the heat is lost from the sharp body. Same way. Here electrical charges are also lost from the sharp points. This is called as the action of points. Losing charges easily from the sharp points is called as action of points. The lightning conductor we discussed before, made by Benjamin Franklin. The lightning conductor protects the buildings from high voltage, high current coming from the clouds. This lightning conductor has a sharp edges. Sharp points should be required, so that charges can easily be taken and also given out from the sharp points. This is called as an action of points. Charges leak easily from sharp points of the object into the atmosphere. This is called as action of points. And this action of points is not there. This points is not there for your syllabus actually. But losing charges from the sharp points is a concept required. No need to remember that action of points terms. This action of points term remembering is not required. Lightning conductor has sharp points. And one of the principle of action of points. Spear can holds charges for long time compared to cubical, conical body, because sphere do not have sharp points or corners, but cuboids or cube cone has sharp points or edges, or can call it as corners. For the sphere, charges. And you, at this point, you will find more charges called the surface charge density, and the charges on the surface is called surface charge density. It is more near the corners than other places. So air molecules coming and picking up the charges. For the sphere, it can pick up one charge, here it can pick up more charges. So from the corners, charges lost very easily compared to the surface where the corners are not present. Next is basic properties of electric charge. Basic properties of electric charges. This is generally asked for 3 marks and important. But this topic, first topic, electric charge and fields, total marks is 8 marks allotted for this. 8 marks total topic. For these properties, 3 marks. 3 properties are there. Just writing names only. You will be given 3 marks. Explanation means they will ask for the 2 marks of each one, or 5 marks may be asked for the explanations. That is different thing. Mostly they will ask you only for 3 marks question. Just write the names only. I will write the names first, and then I will do the explanation of these basic properties of 3 charges. First one is charge is additive. Charge is additive. Second one is charge is constant. Third one is charge is quantized. It's not compulsory to write in the same order. You can write in the different reverse order. You can write this third one as first, second as first also, doesn't matter. 3 basic properties. If they ask you what are the basic properties of the charges, no, write these 3 names. If they ask you explain, Then 4 marks they ask more than 3 marks. Then you have to give the explanation for each one. Give the explanation for each subject. Charge is additive, first one. Second one is charge is conserved. Third one is charge is quantized. Additive means addition, just like the scalar quantity addition. Conserved meaning is constant. Conservation means constant. Quantized, quanta means specific values only available. Whatever you want, you cannot get. That is related to quantization. Separate packets are only available. First one, let us take the charge is additive. Let us discuss the first one in detail. Charge is additive. Charge is additive means if you take the first I added some charge to the object. By rubbing this, I got the charge onto this plastic pipe and then add to this. Touch it and so that some charges are transferred. What I do is I wait for 2 seconds and then again rub it more and then add it, touch it. Previously charges were there. Now also same material again charges will be added to it. Okay. If I rub this with the other material, instead of this I will take other material. Different charges may come, positive or negative may come. So if I take the electric, this is a rubbing with this, this is becoming positive. If I rub with the electric, the fur, then it becomes a negative. I can touch it. So first charge added is Q1, second charge added is Q2. Can be plus, can be minus also. What is total charge on this body means Q1 plus Q2. That's it. Because they are scalar. Charge is scalar. Just like the scalars only we have to handle. That is called as algebraic sum. Plus means plus, minus means minus. The total charge on the object is algebraic sum of the charges added to it. Q equal to Q1 plus Q2 plus Q3. That is nothing but additivity. Total charge on the object is equal to algebraic sum of charges added to it. But in this sphere, metal sphere, I am adding first Q1, next I am adding this Q2, and then adding this Q3 and so on. Total charge is explanation of this. If charges Q1, Q2, Q3 and so on Qn are added to the objects, means actually surface to the objects. Then total charge on the objects is Q total is equals to Q1 plus Q2 plus Q3 plus and so on Qn. If positive charge means positive rate, negative charge means a negative rate. Example we put it. Charges Q1 is equals to plus 2 coulombs, Q2 is equals to plus 10 coulombs, Q3 is equals to minus 4 coulombs are added to the metal sphere. Find total charge on its surface. What is total charge? Answer for this. Total charge Q total is equals to sigma Q also you can write is equals to Q1 plus 3 only I have taken, Q2 plus Q2, which is plus 2, plus means plus, minus means minus, plus 2, Q2 is plus 10, Q3 is minus 4. How much it will be? 10 minus 4 is 6, 6 plus 2, 8. 8 volts. Is the answer. Next, second property. Second property is charge is conserved. Means charge conservation of the charge. Charge is during electrification. During electrification of the object, charge is transferred from one object to other objects. Charge is neither created nor destroyed. The total charge of the closed system equal. System means collection of the object. Closed system means we are not taking some other outside that objects. Two objects I have taken. Glass rod and silk. These two are called the system. One system. I am not considering in the room table is there. Are there with charge taken? Shared by other objects also. Personally, you are rubbing up. Our body also takes some charges. But we should not consider that here. We are imagining that charges are not given to some other objects. We are taking only with this closed system of the glass rod and silk rod. Then charges are transferred from one to other between those two objects only of the system, but not to the third ones. Then total charge is conserved. For a closed system, total charge is constant. For the closed system of the objects, total charge is constant. That is called as a conservation of charge. Charge is neither created nor destroyed during electrification. Of objects. To the electrification of the objects, charge is neither created nor destroyed, but transferred from one object to other objects. In closed system. During electrification of objects, charge is neither created nor destroyed, but transferred from one object to other objects in closed system. This is called as conservation of charge. This is called as conservation of charge. Conservation means constant. So if I take the glass rod, this is a glass rod and silk cloth. Glass rod gets positive charge and talking to the silk cloth gets negative charge. If three charges are there, three positive charges, the glass rod means compulsory you must have three negative charges in the silk cloth. So if you combine it, previously both were neutral, net charge is 0. Here now also you have the three charges. You can transfer only electrons. One electron transferred, two electrons transferred. So what is the charge of this body and the silk is Q2 I will take is equals to 3 electrons. So it is minus 3 electrons because electron charge is negative. And here 3 charges are lost. So 3 protons are more. So what is the charge on this? I will take as Q1 is equals to plus 3. What is the total charge combined? You take this is called the system. System contains the silk cloth and the glass rod. So what is the total charge becomes is Q total is nothing but equal to Q1 plus Q2 which is plus 3 minus 3 which is equals to 0. When means before they were neutral, total charge is 0. Now also total charge is 0 combined. Electrons are not destroyed, not created. They just transfer from one object to other object. Only electrons are transferred, not the glass. This is called as a conservation of charge. And I want to show you one experiment related to this charge creation by friction. It is called the Konnurs Aryabhata. Other property are discussed afterwards, and some more points like this also discuss. Here, by friction, with these some wires, and when the discs are rotated, charges are created by the means of the friction, by electricity. And by means of the induction, the charges are passed through these wires and stored in these jars or the capacitors. And after enough charges are stored, when number exceeds the limit, then a positive plus and minus. Plus is stored in one capacitor, minus is stored in the other capacitor. Plus stored means what? Less electrons. Minus means what? More electrons. And I rotate these discs in the opposite direction, sir. You can see the spark jumping, that is nothing but the jumping of the electrons from more number to less number, from minus to plus. You can see the spark is nothing but the flow of electrons. We cannot see the electrons, loss of energy taking place in electrons and jumping, converted into heat, light and sound. You can oxygen around this breaking into ozone. We can smell that odor smell near to this area. That is because of the ozone formation near the sparks. And in this case, plus minus, only charges were not creating, we are simply transferring plus to one side, minus to other side by means of friction. So total charges before and after remains same. That is related to conservation of charge. Inside the nucleus, we have a